Hello and welcome to Space Forum 2022. I am your host, Bill Flegel. And in just 2 short days, we will be launching worldwide this virtual event. And we'll be showcasing the Microchip Complete Space product portfolio, which is very exciting. We'll also be doing some technical deep dives on specific topics. I'd like to introduce our moderator today, Allison Brown. Hi, Allison.
Good morning. Thanks for having me. So welcome everyone. Thanks for joining us this morning. We are live on YouTube, LinkedIn, and Facebook. If you have any questions that might come up as you're watching our live stream today, please feel free to comment them on any of the posts or email us at livestream@microchip.com and one of our experts will get back to you.
Great, thanks, Allison. And then to discuss this in more detail, I'd like to introduce Bob Vampola. He's our Vice President of Aerospace and Defense.
Oh, thank you, Bill. We're very happy today to introduce our 2022 Space Forum. Our Space Forum this year will be 100% virtual, allowing access to a platform where you'll be able to find our latest news and updates on our portfolio of space applications. You will also be able to find technical deep dives on specific subject matters.
That sounds great, Bob. Can you please tell me a little bit more about what to expect during the week, during this event?
Oh, sure. When our event portal opens on Wednesday, November 2nd, you'll be able to select and view any or all of the webinar content that includes over 30 on-demand presentations. You can register now and even watch the intro by Ganesh Moorthy, Microchip's CEO. If you'd like to be notified of the event, just click the Notify Me button. There's 7 topics with presentations prepared by our best experts. Most presentations are about 20 minutes in length, so they're easily viewed at your leisure. The topics that we'll be presenting at Space Forum 2022 include space market dynamics, including new space, low cost, and fast cycle time. There are also updates and news on a large range of products available for space applications. These include FPGA solutions, mixed signal solutions, MPUs, MCUs, communication interfaces, memory, and frequency and timing solutions. You'll be able to find some technical presentations done by our experts showing system applications and technical dives like solutions for motor control in space. And finally, we have a section on European-centric space solutions.
That sounds like a lot of great information, Bob. Thank you. I know that the mission assurance and flight heritage is key to the success of the Microchip offering. Can you provide some more information around some of those applications?
Sure, Bill. Microchip's portfolio represents more than 60 years of flight heritage. Throughout all of our different product lines, Microchip is proud to have been embedded in over 90 space missions. Most people don't know that when we acquired Vectron, we also acquired an extensive flight heritage. Our frequency control devices were on board the first successful US space mission in 1958, the first lunar landing in 1969, and also part of the furthest man-made object from Earth, Voyager 1. More recently, Microchip has been very proud to have provided many products to support Mars exploration. This includes both the Curiosity and Mars Perseverance rovers. From Apollo 11 to today's Artemis launch, we're here to support the space industry long-term with semiconductor solutions. For example, our RTG4, RTAX, and RTSX FPGAs are featured in both the Artemis launch system and the Orion spacecraft. Our radiation-hardened LX7730 telemetry controller and the LX7720 motor controller, mixed signal ICs, are featured in the propulsion control, communication, and navigation systems in the Orion spacecraft itself. Orion spacecraft is also supported by our evacuated miniature crystal oscillators, temperature-compensated crystal oscillators, and our clocks. Artemis is enabling the use of Ethernet technology for space applications. With our microcontrollers and communication interfaces, Microchip is committed to support this evolution with innovative space solutions. Microchip's portfolio is vast. Our solutions cover everything from discrete diodes and transistors to microcontrollers, microprocessors, complex FPGAs, DC to DC converters, quartz and MEMS oscillators, all the way to ultra-stable atomic clocks. No other semiconductor supplier can offer this breadth of product. For applications in space, we offer a complete line of products rated from radiation tolerant to rad-hard by design, offering our clients solutions suitable for LEO, GEO, and interplanetary missions. In Space Forum 2022, we'll be presenting the latest news on our anchor products. FPGA solutions such as RTG4 and RT PolarFire, mixed signal solutions such as the LX7720 and LX7730, our MPU, MCU communication interfaces and memory such as the SAM RH71, the SAM RH707, and the VSC8541, a rad-tolerant Ethernet PHY. For frequency and timing solutions, we offer a large range of crystal-controlled oscillators and space-grade chip-scale atomic clocks, or CSACs. From Power Solutions, we'll present our DC to DC power converters along with our newest rad-hard MOSFETs. Microchip is the right solution for space system design.
Thank you, Bob. I appreciate that very much. And I'd like to maybe show some of the products today that we actually have. So I'm going to show over here, this is actually our CSAC, our chip scale atomic clock, for those applications with a GPS denied environment. This is an exciting product we developed with DARPA, and it's actually out in many applications today. The next product is the RTG4, our latest FPGA for radiation tolerance. This is actually out today and being designed and flown today in multiple applications in space. Then I'd like to show here, might have to zoom in a little bit to see the size of this chip, but this is our VSC8541 communication device, our RT PHY. This has been out now for a few years, started in Europe and has now been coming into the United States and doing very well in many designs and many applications, including the Orion spacecraft. And then if I look at the last product, this is a new release. This is the SAM707. We already have this out today for development, and we get into full production at the end of this calendar year. This is one of the products that we'll be featuring here at the Space Forum coming up this week. So one of the key here is that Microchip is going to be the right solution for space designs, which is very critical for mission assurance. Why is Microchip the right solution when designing for space?
Good question, Bill. We offer a wide range of mission and application-specific solutions. Onboard computing, telemetry tracking and control, guidance and navigation are all examples of Microchip solutions that deliver complete end-to-end performance. If your system requires processing, interface, control, communications, RF, time and frequency, or power delivery, we offer complete confidence in the reliability and performance required to accomplish your mission. Microchip also has support from FAEs around the globe and an in-house team of radiation effects experts for modeling, simulation, and testing. All these experts have contributed to the Space Forum preparation, and you'll be able to get great tutorials from our best engineers. Microchip understands the mission assurance vulnerabilities that come from insufficient quality and reliability and provide products and solutions that have been designed, tested, and qualified to mitigate these issues. In addition, we also offer a suite of implementation and evaluation subsystems that include software IP and development environments that enable our clients to start their designs with unprecedented speed. Here you can see a motor control solution featuring a SAM RH71 and the LX7720. In-flight reprogramming featuring our SAM RH71 and our RT FPGA, and a telemetry monitoring solution utilizing an RTG4 and the LX7730.
That's great, Bob. We also hear a lot today about new space and the commercialization of space. What does Microchip's portfolio do to address this market space?
Yeah. Well, the accelerating and rapid deployment of large constellations of low Earth orbit LEO satellites, CubeSats and nanosats is transforming how the space industry looks at its supply chain and component reliability requirements. By registering to our Space Forum, you'll learn about Microchip solutions for new space. For new space applications, it's important to have in mind some key points. First is Microchip's commercial leadership. Our new space offering is based on high-volume commercial off-the-shelf products. Microchip is also recognized as an MCU and FPGA market leader, as well as a leader in connectivity, Ethernet, domains, and security. Second is Microchip's longevity and leadership in space with more than 60 years of flight heritage, with a strong expertise in radiation and recognized qualified portfolio. Third, you'll learn how we take each of the strengths just mentioned to provide a few options for new space programs. We employ a sub-QML process flow with devices that capitalize on a space heritage from radiation hardened by design, or RHBD. Packaged in ceramic or plastic, these devices reduce overall costs while limiting the redesign efforts that would otherwise be needed for qualified space systems. The first option is a top-down approach in terms of cost-cutting strategy. An alternate approach is our COTS to radiation-tolerant solution. Here, a device based on the original COTS design would be enhanced to provide radiation improvements, including full latch-up immunity in space. Though the devices were not initially designed for this environment, they're selected to achieve between 20 K-rad to 50 K-rad TID radiation tolerance and then packaged either in ceramic under a QML equivalent flow or plastic under high reliability quality flow. This provides the optimal qualification level at a lower price with full traceability. The second option can be extended to target COTS to rad-hard devices. We have tested and qualified advanced COTS architectures to create rad-hard solutions that reach greater than 100 K-rad radiation immunity with low SCU error rate. With this COTS upgrade approach, both RT and rad-hard by design devices become part of the same device ecosystem as the initial COTS device.
Wow, thank you, Bob. That is an excellent overview of what to expect this week. Maybe let's take a look at how our visitors could join the Space Forum. Allison, can you please share how folks can register and sign up?
Yes, absolutely. So let's take a look at our registration page, which is going to be microchip.com/spaceforum. On this page, you can find out information about it, as well as be able to watch each webinar once the portal opens on November 2nd. If you'd like to be notified of the event, you can click the Notify Me button, and that'll sign you up for those notifications. And just to answer a couple questions, the registration is totally free, and once you register for the event, you'll be able to view the webinar videos for up to 1 year after it's over. All right, and now we do have some questions for you guys. So we'll get started with this one, which is, are there any other ways I can be updated on Microchip's latest product news for space?
Sure, I'll take that one, Allison. So we have a Space Forum. Outside our Space Forum, we also have a quarterly newsletter, so you can sign up for that at our website at microchip.com, as well as other information that should be able to provide what you need.
Perfect, just what we're looking for. This next question asks, I have seen press releases from NASA JPL regarding a high-performance space compute program. Will you be giving more information on this program?
I'll take that one, Allison. So Microchip's HPSC processor is a high-performance, multi-core SoC architected with reliability, fault tolerance, security, and low power in mind. It will deliver comprehensive Ethernet networking, advanced AI/ML processing, and connectivity support while offering unprecedented compute performance gain, 100 times over what is used by NASA today. Additional details on HPSC features will be made publicly available by Microchip at product launch, though.
Awesome, thanks, Bob. This next question asks, how do Microchip space FPGAs meet the size, weight, power, and cost challenges in space?
Oh, okay, good question. Our radiation-tolerant and commercial FPGAs have always had immunity to radiation-induced configuration upsets, thanks to our programming technologies and design techniques. It means designers don't have to worry about scrubbing and reloading the FPGA configuration, which ultimately is a saving in power consumption, as well as bill of material costs and board space. Components that generate a lot of heat create thermal management problems, which are expensive to solve. They add weight. The programming technology that we actually use in our FPGA gives us intrinsically low static power, which helps system designers manage the thermal issues in spacecraft. And we have many families of RT FPGAs with various qualification levels in order to offer a range of solutions that will help provide solutions where cost is crucial. But to learn more about the RT FPGAs, please register for the Space Forum to get access to more information.
Great.
Thank you. All right, and this next question, can you please elaborate further about the analog capacities of the new MCU SAM RH707?
Oh, great. What I suggest that you do on that one is to join the Space Forum starting on November 2nd. We're going to do a very deep technical dive into that product and many others.
Great, thank you both so much. That's going to wrap up our question portion. If you're watching and you had a question that we weren't able to get to, please feel free to comment it below or email us again at that livestream@microchip.com email. One of our experts will get back to you. We hope to see you all at our live event, and back to you guys.
Great, thank you all for joining this telecast today, and we look forward to connecting again at the Space Forum kickoff on Wednesday. Thank you.
Thank you.